Hello, is this thing on? Hello, is this thing on? Okay, yeah, it's on. Phew, here goes nothing. Hi. Um, yeah, today we're gonna do math. What time is it? It's 3:42. I was supposed to do this at 3. I just keep procrastinating. I don't do anything productive in my life. It's been 12 days since I really studied anything. Sometimes I worry about how my life is gonna turn out, and I don't know. I have a feeling things are gonna go really bad for me if I don't start studying. So I'm gonna turn on the camera, and even though I don't know anything at all, I'm going to just start writing stuff, I suppose. Because, in this life, you have to be confident that things will turn out alright, but you also have to work hard. As you know the saying, hard work will not betray you. So, hard work will not betray you. So, if I work hard right now, it won't betray me. I think that's how it works. So, we're gonna study Calculus 3. What was I doing? I don't even know. I literally have no idea. We're gonna look at double, we're gonna look at independence of path, we're gonna look at line integrals or something. I don't even know. I don't even know what I'm gonna look at. That's how lost I am. Okay. I should probably. The resources I'm gonna use are the OpenStax Calculus 3 textbook, Paul's online math notes, and this other book, Advanced Engineering Mathematics. I don't know. I don't even know if I'm allowed. Or am I supposed to? I guess it doesn't really matter. It's gonna. It's gonna get me. Okay. So we're gonna talk about line integral. So I think you know that when you integrate stuff, it's like you're trying to find the function defined over an integral. I mean over an interval. So let's say I want to find the integral of this triangle or something. Uh, from like 2 to 3. And then you take this integral of this line or something, and then you go like, okay, let's say this function is x. So when you take the integral, you know what, do I even know what an integral is? Like now that I really think about it, 2 and 3. Uh, can you guys even see that? Can anyone see this? That's better. If I change it to white. No. Yeah, I guess that's okay. Whatever. I guess you guys are gonna have to deal with it. So this is, well, basically this is kind of an introduction, but this is basically for people who already know like how to do integration. So here's from 3 to 2. So you plug in 3. 3 squared is 9, divided by 2 is 9 over 2, and then subtracted by 2 squared, which is 4 over 2. And then you're like, what's the answer? It's 5 over 2. So then, okay, maybe I have to look up what even integration is, because I guess I don't know. What is integration? I've been waking up at such like terrible times. Like I just cannot sleep anymore. Like my circadian rhythm is busted. There's something wrong with it. So yeah, I think basically I was able to explain it correctly. So now we're gonna look at this thing called line integrals, and this is good for me too. Yeah, so I haven't been sleeping. Oh, I should finish like one story at a time. I just haven't been sleeping, and I wake up at weird times, and then when I wake up, then I gotta do all this stuff. So I just end up like going back to bed, so I don't have to like have any responsibility in my life. But like, I think I have to get a grip. Okay. So now let's say like it's like this or something. Let's say that this is This is a line. Okay, so obviously it's not as simple as just x, right? As this triangle. Well, it's not a triangle. It's like a line. So this is like, oh, it's a weird formula. And then you go down like this. And then you're like, I want to find what's in here. Or let's say like there's a second line. Now I gotta find what's in here. Okay, so you can't use normal integration to find what's in these things. So we use this technique called line integrals. You know what? I think I'm just a yapper. I actually don't even know what I'm talking about. That's why I guess so insecure to stream, because like what am I even talking about? But like I don't know. But hard work won't betray you. You know? That's what they were telling me those days. That's what they've been telling me. Suppose that C is a curve parameterized by, so C, whatever C, okay, no, not like that. It's like f, x equals f of t, and y equals g of t, where a is between t and b, which is just like two random numbers. It can be like 1 and 2, it can be like 3 and 4, so it can be negative infinity to positive infinity. So whatever. A and B, I'm doing this thing a lot. Oh, hey. Oh, hey. Hey. You understand? You guys understand? Hey. Okay, whatever. C is a smooth curve if f prime and g prime. So if you take the derivatives and it's close, and if it's continuous, I don't know. I don't really know what that means. It's not simultaneously zero on the open interval. So I think it means like this. Okay? And then a piecewise smooth curve is like this. They're connected. So this is one line segment and it ends here, and this is another line segment. It's a closed curve if A equals B. So what is a closed curve? It's a circle. So if it goes around and they go on the same loop, it's a closed curve. Okay, I'm trying to look at this. It's a simple closed curve if it does not cross itself. So this is simple and this is not simple. If it like goes over itself. It's like if you have a string and make a circle, okay, yeah, that's a simple curve. And then if you like fold it on itself, then obviously it's not simple anymore. It's quite complex. Okay. Yep. And I guess I got it all correctly because it's showing me. It's showing me that. The same terminology carries over in a natural manner to curves and spaces. Okay, fine. Okay, I guess I agree. The definite interval. Before defining integration along curves, let's review the 5 steps. Let y equal f of x be defined over a closed interval. So what does that mean? It means it means that it's not like it means that it appears on the thing of A and B. So yeah. Probably makes sense. Partition them into subintervals, n subintervals, xk minus 1. So probably like one piece here, one piece here, one piece here, one piece reference. This is just like the one piece reference. Okay. There. So you just cut into a bunch of pieces and then let p be the length of the longest subinterval. The number p is called the norm of the partition. So basically now I don't know what's going on. This is p, and it equals x squared plus y squared root, something like that. Use a sample point in each interval and form the sum of the summation n with k minus 1, something like this. K minus 1. K equals 1, sorry. It's not minus 1. And then fxk is k. Okay. Whatever that means. Line integrals in the plane. The following analogous 5 steps leads to the definition of 3 line integrals in the plane. I wish I knew what this meant. Form the sum. So basically, okay, I kind of remember this. It's like, here is A, and then you divide it up into a bunch of parts. And like this. B. Okay, and I guess it's getting in the way. Oh, hey, opossums. How's it going? Now, why are we both awake right now? I don't know. Well, yeah, actually, I know. I've been having a lot of trouble sleeping lately, and I just haven't been doing anything productive with my life, so I thought I would get up and try to do something, I guess. So right now, I'm trying to solve some math problems, or I'm trying to figure out how to do mathematics. Why am I doing math on a holiday weekend? It's a holiday? Oh. Oh. I guess that means, oh yeah, it's Thanksgiving, right? Is that it? Happy Thanksgiving, I guess. I live in Canada, so I had Thanksgiving a while ago. I guess that means you. Yeah. Well, happy Thanksgiving. Hope you have a. Oh, that's on Monday actually, isn't it? Okay. Yeah, well, what about you? Why are you awake? So you can't sleep. Like, I go sleep at 8 o'clock, right? And then I wake up at like 2, and I already slept for 6 hours, so why would I? So I should hypothetically be fully rested. So I just get up and eat breakfast. Canadian friend told you when it was Thanksgiving. Yeah, that was a while ago. That was like in October. But anyway, that's just it's just how it is. Okay. Let g be a function of two variables x and y, defined on a region of the plane containing a smooth curve. Line integral of g from c from a to b with respect to x is blah blah blah. I have an exam soon, so I have to work really hard. So I need to get like I need to get together. G of x, okay. So basically it's like this. You have a curve, right? And you have the function of g of x and y, which is basically just a function. So it's like I don't know, x squared plus y squared or something, which is the formula of a circle. And then you're supposed to take the okay, yeah, I don't. You're supposed to multiply it by the derivative of no, it's all wrong. I did it all wrong. You're supposed to define it parametrically, which means something. It means you're supposed to make it like possible to be on the curve or something. By f prime of t. So you're supposed to derive it to get f prime, and then you multiply by dt. And then for the next one you do the exact same thing, but you multiply by g prime of t, so you take the derivative of g. This capital G and this little g are different actually. And then you're supposed to take the norm of the curve, which is f prime of t squared plus g prime of t squared, which is basically just x squared plus y squared, like whatever x and y is, and then you root it dt. And then you're supposed to do that for the with the derivative with respect. No, you're supposed to take the integral of the thing with respect to x, with respect to y, and with respect to the arc length, or something like that. Okay, so now we go to this problem. It's pretty messy over here. But we're supposed to go to... Okay, so here's an example. It's gonna be like this from this. Here's the 0.40, and here's the 0.40 over here, and t equals pi over 2. Let's see. Okay. It's all curved and you guys can't see it. Okay, so now it's gonna ask me evaluate the integral on the line. So they want me to evaluate this xy squared with respect to dx, dy, and ds. Okay, so let's start with dx. So, and where x is defined by x equals 4 cosine t and y equals 4 sine of t, where t is between 0, t, and pi over 2. Okay, so basically we're gonna have to find our dx, right? So what's the derivative of x? Well, first of all, x is 4 cosine t. I don't know if you guys can see it. Yeah, you guys can probably see it. So now you derive it. So the derivative of cosine is negative sine. Is that right? Yes, it is. No. Yeah, it is right. So negative 4 sine of t. And a professional tip, if this is t, if it was 2, you would have to take out the 2 and multiply it. Just in case it comes up later. But actually, maybe I should have mentioned it because... Okay, anyway. So now this is dx, right? This is what we're going to multiply it by. So now we have x and y squared. So in order to convert it into a parametric equation, you're supposed to find what x and y are equal to on this curve. Now, I actually don't know how to find them parametrically, but good thing it tells you. It tells me right here, x equals 4 cosine t and y equals 4 sine t. So that means I can directly substitute it inside. So 4 cosine t times 4 sine t, this is squared because y squared over here, and then multiplied by dx, which I found over here. So multiplied by negative 4 sine t, and then dx just goes away, and it's actually becomes dt now. I don't know where the dt comes from. They just like added in because you just need to have it. And then this, we know our interval because it's from pi over 2 to 0. So here's pi over 2 and here's 0. So this is the full integral. So our first step, we should square this so it becomes like easier. So 4 squared is 16, sine squared is sine squared t. Okay, so let's just get that out of here. And then these are all being multiplied, right? So the idea, or my idea, is that you pull out the 4, the 16, and the negative 4, so that you can just have these by itself. So 4 times 4 is 16, and then 16 times 16 is 256. But just let me just check again. 6, 9, 6, and 1. 2, 5, 6. Yeah, that's right. So now you take it out here, and it's still pi over 2 and 0, but you just take out the 2, 5, and 6. So this 4 goes away, this 16 goes away, and this negative 4 goes away. Oh, actually it was negative. So don't forget that. It has to be negative. I almost forgot. So now I'm going to combine like terms, which is cosine, sine squared, and sine. So sine squared times sine is sine cubed t, and then this is just cosine t. Okay. Now this is a pretty tough integral, I suppose, but in order to solve it, we have to use u substitution. So what we're gonna do is we're gonna let u equal sine of t, and then the derivative of u, and this is also dt, it equals cosine, or is it negative cos? No, it's cos. It's cos of t. When when cos goes to sine, it becomes negative, but when sine goes to cos, it stays positive. dt, okay? And now dt is supposed to be over here. Sorry, I forgot to add it in. So now I'm trying to get it in terms of du. So I didn't understand this for a long time, but like the reason we do the du is like when you derive it, you know, x becomes dx when you derive it, and y becomes dy when you derive it. Okay, that makes sense. This dt is always there because it's like the, I don't know, like the prefix of this equation. So you're trying to, if you want to get it in terms of u, you can't integrate u with respect to dt. It has to be with respect to u, because that's the thing that's being like taken care of, I suppose. So now, in order to isolate for dt, I have to divide it by cos. So this cos t. So now this cos goes away, and then I have my expression t. So now I can take this and I can stick it right in here. So du over cos t, this is cos t over 1, so they cancel out because it's like cos t times cos. They go away. Bye-bye. So what was all that to accomplish? And I'm running out of space. Very usual. So now I know that u is sine t, so I have u cubed. I have sine cubed over here, so it's u cubed du, and remember the cosine goes away. And then it's pi over 2 over 0. So now actually what I'm confused about is, am I supposed to, because I changed it to u, should I change this? But actually no, I didn't change it to u, because now I take it out and it's gonna be wait. Okay, well I guess I'll just solve it because it gives me the answer anyway. But if you integrate u cubed, you do the rule u4, and the rule is that you add 1 here and then you divide it by whatever this number is, 1 over n. Okay, and now I replace it with sine. I'm gonna move over here now. So now it's sine 4t, and now that I took it, you do pi over 2 and 0. So in order to figure that out, I look it up because I don't know how to do it. Sine 90 degrees. I think it's root 2 over 2. No. So here you do it, and sine pi over 2 is 1 to the power of 4 minus, and sine 0 is 0. I know that much. The power of 4, which is just 1. Actually, I feel like that's not right, so now I gotta go look it up. I'm pretty sure the answer was 0. No, it wasn't 0. It was, actually, hold on, wait. And by the way, while I was at it, I forgot the 256 negative. So now it's like this. This was 1 over 4. I forgot the 1 over 4 too. I take it out, you divide it by 4. This is 1. So now, okay, what a mess. Negative over 4 multiplied by, and here is 1 minus 0, right? So it's 1. So now 256 divided by 4 is 64. Negative. And that's it. That's the answer. Okay, so that was 1 out of 3. So now I have to do that all over again. Except I actually practiced the first one, but I didn't practice the second one. So now we do all that, except we have to plug back in 4 cosine, or we have to do that, but we multiply by dy. Okay, so now here's dy. Okay, so now basically, what's the derivative of dy? Well, let's put our x and y back. 4 sine t. Okay, so now the only important part is we find the derivative of y. equals 4 cosine t. Okay. So now we go and we do all that over again, but I'm pretty sure this requires a double angle formula. And for that, I have to go review what double angle formulas are. I was never good at trigonometry. My weakest. It was where I was the weakest. And then the interval is still the same, which is pi over 2 and 0. So step 1, let's take all our 4's out. So 4, 16, 64. 64 cosine squared t and sine of t. Pi over 2, 0. Okay, but now that I think about it, I feel like I can solve this with a u substitution again. So let's say u equals cosine, du equals negative sine, t, and oh, and I forgot to put in, no, I did put it in. So now, and this is still dt, now I have to divide over here, so du over negative sine equals dt, and I keep forgetting to put dt over here. So now I have negative sine here, and I have sine over here, and this is sine over 1, right? So once again, it gets cancelled out. That's like the general rule. When you're looking for a du, you have to find, like, I guess like the guy that you sacrifice to get like this by itself, because it's really hard to integrate, or it's like basically impossible to integrate that. I don't know, maybe there's like an easier way later, but you do that, and then you have your du, and then you take the negative and you put it outside. So negative 64 pi over 2, 0, u squared. Remember, it's cosine is u now. Du, and now you integrate, which is, now you get it, it's 1 over 3 u cubed. Du goes away, I guess it's like plus c, but I don't really know. Pi over 2 and 0, and this goes back to being cosine cubed. And then you take the 1 out of 3 and you take it out. Okay, what a mess. Negative 64 over 3. And you take it out, right? And now you just have cosine cubed. Pi over 2 and 0. Now of t, so cosine at 90 is probably pi over 2. I mean root 2 over 2. Let's look it up again. Okay, it's 0. So pi over 2 times 0. Pi over 2 to the cos, pi over 2 is 0. Cubed is also 0. Cosine at 0 is actually 1. And then cubed is 1, right? Let me look. I should really know this. I should really have memorized this, but you know. And even if you cube it, it's still going to be negative, so I don't have to worry about that. And now I multiply by 64 over cube, so now it should be 64 over, because the negative here gets multiplied by the negative there, and it becomes positive. Okay. Let's go look. Okay, I was wrong. Okay, let me just think for a second then. Oh, I freaking forgot. I forgot to square it, man. I forgot to square it, man. Idiot. Oh, come on. Okay, now I gotta do everything over again. Ah. Okay. Okay, fine. It's all wrong. Just ignore everything I said. Also, I'm not a professional mathematician. If you're watching this, you know, maybe to like get better at math, you should definitely just go watch like a Khan Academy video or an organic chemistry tutor, or even go look up Paul's math notes. Paul's online math notes. Because he's actually, like, I was looking at it and he's really good. Like, he has all the answers. And it just seems like he's a really knowledgeable guy. Oh well. Okay, so now let's do it again. 256. Okay, I'm gonna do like well, a little faster because now it's here's cos squared t, here's sine squared t, and now I'm just looking at the answer, but like, well, I don't know how to do this. You're supposed to use some kind of trigonometric identity, so now I'm gonna have to go review what trigonometric identities are. Trig identity. Okay, so basically, just give me a second. Just give me a couple days. If you multiply them together. Okay, wish it would tell me. I think this is the okay, probably this one. Sine and cos. Sine. Cos squared and sine squared. Same, right? Yeah, I think I might be done for. What if I did it like this? So I have cosine and sine, and then you do 1 over 2 sine 1 plus a plus b, which is 2t, minus sine, which is t minus t, which is sine at 0. Okay, and you have to square it. So you go here and you multiply it by itself. Sine 2t minus sine 0. Okay, here, hold on. I gotta teach you guys the trigonometric identity. So when you multiply cosine by sine, like of x or t of t, basically the same, it equals half sine a plus b minus sine a minus b. Where, no, yeah. Where a is what was in cosine, which is 1, and b is what was in sine, which is also 1. And what I did here is because both of them are squared, I thought I would be allowed to square it. So that's what I did. So now if I were to multiply this, well, let's say sine at 0 is 0, right? So it goes away. Bye-bye. Sine 1 of 2 and times 1 of 2, 1 over 2 is 1 over 4. And then all you have left is sine 2t and sine 2t, which is just sine squared 2t. And that's exactly what they did. Okay. Now this is dt. And then basically what they did was and don't forget about the 256. Was it positive? It was. Divide by 4. You take out this 1 over 4. Okay, get out of here. 64. And now you have sine squared 2t. That's what you're left with, right? And in order to do it, like there, now you gotta use another trig identity. So now I have to go look at which one it is. I drink some water too. Oh, I don't have any water. To go get water. Okay. Be right back. Water break. turn this thing off? No, I didn't. Okay. Get out of here. So now you have a sine squared and okay. So sine 2 sine squared 2t could be God. Wish they would tell me stuff with half minus cos. What? Sine squared 2t trig identity. Okay, what? Okay. Sine 2x equals sine squared sine 2t equals 2 sine t times cosine t. Now you square it, which is multiplying it by itself, right? So 4 sine squared t cos squared. Like, how is that possible? Is that right? It's not even. God. Over 4 2. Basically, what they're trying to 2 cosine t was this. Why? How? Maybe my something. This, my desktop audio. Okay. One minus 2 sine x. This one. If I don't figure this out, then how am I gonna know it on the test? Okay. Guess I'm not. 64 pi over 2 0 half 1 minus cos 4 t. So now you take out the half, which is half times 64 is 32. And then integrating this is t minus 1 over 4 sine sine t. Okay, and now you take pi over 2 0 and then you put it. So here's pi over 2 minus pi over 2 here times 4t. which is 90 times 4, which is 360, which I think is 0. It is 0. So here's 0, and when this is 0, it's also 0, so it's pi over 2 minus 0. So times 32, it's 16 pi. Okay. That's correct, but only because I got the answer from the thing. So now, okay. So now we have the one for dx equals negative 64, the one for dy equals 16 pi. And now you have to ask what does the one for ds equal. So now we have to find it, which is, the formula is for ds, which is arc length, is x squared plus y squared rooted. Okay, so that would be 16 cosine squared t times 16 sine squared t, all rooted, which means that, well, basically what they want you to know is that with the trig identity, cos squared t plus sine squared t, it equals 1, right? And now they're telling you that this is 16. So 1 times 16, they're telling you, what they are telling you is actually that since this is 1 and this is 1 and you multiply, I'm pretty sure it's 16 or it's 32. It's 16. Is it 16? What they want you to know, like realize that, is that cos squared plus sine squared equals 1. And then it's 16, and then you root it and it equals 4. And then they want you to do 4 cosine t, this is just x and y squared, 16 sine squared t, and 4, and dt. They want you to take it from pi over 2 to 2 to 0. So now you pull it all out again, it's 206 pi over 2, 0, cosine t, sine squared t, and you're supposed to take the, I don't know, you're supposed to do u equals sine, du equals negative cos, positive cos, dt, and du over cosine equals dt. Okay. Here's dt also, I almost forgot. Now this goes away and this goes away. Now it's u squared, integral, take it 1 over 3 u cubed. Now you take it, now you replace whatever is with it. I'm gonna move it over here because I want to get as much space as possible. So here's 1 over 3 sine cubed t, pi over 2, so we know that pi over 2 is 0. Sine 90 is 0, cubed 1, 0, 0, it's all 0, minus 0. Is that really true? No, it's not true at all. Hold on. Oh wait, sine 90 was 1. Okay, even after I did it for like 1 billion hours, I forgot. So it's going to be pi over 2 and 0. It's going to be 1 over 3 because this is 1 minus 0 times 256, like this. So now it's 256 over 3. That's the answer. Okay. Method of evaluation. Curve defined by an x-split function. Okay, hold on. I gotta drink some water. Okay, some delicious water. Can get back. So here, I think they introduce a shortcut. they're saying that, what are they saying? They're saying that the parameter with respect to x makes the line integral easier somehow. This is EA GXF f of x dx. So this is the one with respect to dx. We already knew that. This one becomes g f of x f prime of x dx for y, which is like equal to dy, the integral, and then the integral of the arc length one, ba gx f of x root 1 plus f prime of x squared dx, which they're saying is equal to arc length. This is equal to x. Okay. So basically I have no idea what that means, but hopefully I can figure it out. A line integral along a piecewise smooth curve C is defined as the sum of the integrals over the various smooth curves whose union compromises C. For example, if C is composed of smooth curves C1 and C2, then gxy ds gxy ds plus C2. I guess I should supposed to read it. In many applications, line integrals appear as a sum dxy dx qxy dx. It's common practice to write this sum as one integral without parentheses. So basically, in essence, they're trying to say that after all that, there's this like easy way to do it, which is p dx plus q dy. And this leads up to Green's theorem like in a little bit, but after we do our double integrals, our triple integrals, and our divergence theorem, okay, I think something good will happen to me if I try my bullet. Okay. Take a 5-minute break. Be right back for 5 minutes. Okay, be Okay, hello, I'm back. This thing on the microphone. Oh my god, I'm so tired already, but I went to sleep for literally 6 hours. Like, how is that even possible? Okay, so the whole point of the px and dy is that they're telling you x, y, now they want you to evaluate this other integral, x squared dy, where c is given by y equals x cubed. That's just it. And then with the between the parameters of 1, -1, and 2. So they're telling you that y equals x cubed and this is dy, right? So you just have to take the derivative, which is 3x squared, and then you just plug in here. And you know that x... Okay, hold on. Oh, plus dx. But basically, this dx, you just leave it alone, and then you replace the y, or you put in y. So this is x times x cubed given from y plus x squared multiplied by 3x squared dx. So now if you were to multiply it, it's x4. This is plus 2x4, which adds up to 3x4 from 2 to 1, from 2 to -1. You take out the 3 as well. And now if you were to do that, it's 1 over 5 x5 given by 2 and -1. Now that's 2. 2 to the power of 5 is 32, so it's 32 over 5 minus 1, which is plus 1 over 5. There's 33, 5 multiplied by 3. So it should be 99 over 5, but last time I checked, that's not the correct answer. So let's go look. Yeah. Yep, I was wrong. Again. Okay, well, let's figure out why. It's because this is 3. So it's not 3, it's actually 4. So this is supposed to be 4. So 33 times 4 is 99 plus 33 is 12 and 13. 132 over 5. Which is the correct answer. Oh, also. Basically I messed it all up, but I basically told you. Alright. Okay. So tired. I thought that this was gonna be better. Also, I think I have to get a haircut in the morning. I don't have a choice. My hair's been growing out a lot, and you know what I've actually been doing? I've just been cutting my own hair. Like, I just grab a pair of scissors and I reach up there and I go around the back and I just do not, like, don't care, because it's been like, you know, when you're like scratching, or like when you're, what do you call it? Sorry, oh my god, I'm so sleepy. When you know, take a pair of scissors and you just cut your hair, you know, snip snip, you cut it off. Obviously it's gonna be uneven, and then like when it itches your hair, you get like so annoyed, right? That just really is, you know, that really kills me. Okay. Go here and you look at the x. So now they're just throwing us into an example, x dx, where c is the circle, x equals cos t, y equals sine t, between the interval of 0 and 2 pi. Okay, well, basically we've done all this, right? And it doesn't look like we have to pay attention to Looks like we don't care about y for some reason. Just have x, and we know dx equals negative sine t. So now we have cosine t, negative sine t, and between 2 pi and 0. Dt equals. Okay, this might be a half angle formula, but I don't really know. God, I'm so stupid. Oh, hey man, don't put yourself down. You've been trying your best. That's what matters. Except, you know what? Hot take, it's not what matters. You have to do everything correctly if you even want to have a chance in the workforce. You know, if you want things to go well for yourself. If you want something good to happen to you. But even if you work hard, nobody's gonna care. Nobody cares how you do it. Nobody cares, you know, if you tried your best. You don't produce results. Sine 2t sine 0t is 0. Is that correct? It's not correct because I'm looking at it right now. Oh, can't I just use the... Sorry, this is a... Okay, this is a u sub. du equals sine... u equals sine, du equals cos. Alright. T, get the drill, right? Cosine dt. Get out, put it in. Now it's negative u. Take out the negative, integrate it. Half u squared. And no matter what you do, whether you take sine, whether you substitute sine or cosine, it's negative half sine squared t, and then you take 90, which is pi and 90. Hold. I keep looking it up even though I know the answer. What about 0? Oh, it's not supposed to equal 1, but for some reason, getting it wrong. I think it's because I took sine. Do it the other way around. How is it wrong? Oh, it's not, no, it's not, it's 2 pi. It's at 2 pi, which is 360, which is 0. 0 minus 0 equals 0. If you did it the sine way, you would get 1 minus 1 equals 0. Okay. So tired, and it seems like everything hurts. Such a complainer. Every time I go to school, I have to carry this big backpack around with me, and it just keeps hurting my freaking back, man. Okay, we're about to get to... Yeah, we're not even close to done yet, and this is just one section. I have like I have 8 more seconds to go. Stop. A closed curve. Oh, I guess this is gonna be like this or something. Circle, but it tell you evaluate y squared dx minus x squared dy. On the closed curve that is shown at blah blah blah. Shown on figure 8.3a. 9.8.6a. Talking about here. So basically, it's like this. This is the shape we have to find. So this is 0, 0, 0. This is a 2, 0 because the x and y goes up here. This part is 1, 2, 3, 4. This is 4, 2. And it goes down like this, not a straight line, where y equals x squared. So basically the whole point, or the culmination of the... Oh crap, I did it wrong. It's not 4, 2. Oh, it's 2, 4. Okay. This part I always mess it up, but basically they want you to look at this line, right? It's going this way. They want you to pay attention to like y equals 0 and x equals 2. So since x equals 2, you go like this. X equals 2, y equals 0, right? Because from here to here, that's what the change is. So since x equals 0, they're saying dy equals 0, and they're saying dx equals 0, right? However, so they want you to plug it in or something. So here is 0. It's all 0, right? Basically, it's all 0 except x squared, which is 4. But like if you go up there, I'm going to go up there and I'm going to take a look. Well, basically it's 0, right? That's true. Okay? Okay. That's true. Okay, I agree. So they're basically saying the integral here is equal 0. Don't worry too much. And then here, that's what for this line. That's the integral for this line. And you see that it's a straight line, right? And a straight line means that there's no change in the blah blah blah, in the whatever. So it makes sense that the integral here would be 0. So now you look at the integral here. 2 to 4. So where x is 2 and y is 4. So now you go here and you look, and since x is 4, then I guess they're suggesting that this is 16 times dx, but since it's dx, and here it's going to be 0 anyway, so shouldn't it all be 0 is my question. So this is going to be from 2 to 2. It doesn't change, which means the change is 0, but like x is 2. And from here to here, it's 4. So it's 4 and 2. So here's 2, 4, but shouldn't it all be 0? But it's not 0 for some reason. So let me just look for a second. It should be that. Okay, hold on. I'm just having so much trouble. God. Okay, since both of them were 0, but since dy here, we don't worry about di since we're using it as a parameter. So dy here, it doesn't matter what dy is. So we just leave dy like by itself. But we take care for dx. So look, x equals 2, dx equals 0. Okay? I'm trying to figure this out myself, so bear with me. Now y squared times dx, well, we know it's 0, right? 0. minus x squared dy, well, it's okay. We don't have to worry about what dy is because we're not focused on the parameter of dy. So now we have x squared, which is 2. So it's minus 4 dy over here, where it's supposed to be from, well, here is from, it doesn't even matter. Here's from like 0 to 0, so no wonder it's 0. Here is from 4 to 2? 2 to 0? No. Holy crap, I'm getting mad. No, it is from 4 to 0. Here's 4, it goes up 4 and it goes to 0, so there's your boundary. Looking for here. So now you take it and it's negative 4y. It's not, yeah, it is. It's negative 4y. Then 4 and 0. So now it's negative 16. So there's your answer. And then here is where it gets complicated, obviously. So since you have y equals x squared, you know that dy equals 2x. So I'm going to use the parameter of y, and I'm not going to worry about what x is. So now, here, remember this is this formula. So here is x4 dx minus x squared, and dy is also 2x dx from the interval of, it looks like 2 to 0, since we're focusing on the x. So all that's correct, and this is x squared times this should be x4 minus 2x cubed dx, 2 and 0. And now we take it as 1 over 5 x5 minus 2 over, well, 4 x4 plus c. C doesn't really matter. Now, I always forgot to put my plus c. If you don't put a plus c, you lose a point. Usually. 2 and 0. So 1 over 5. X to the power 5 is 32. Minus 2 over 4. X to the power 4 times x to 2 to the power 4 is 16. And then 0 is just 0. So now it's 32 over 5 minus 32 over 4. And now you're supposed to multiply it. Or you're supposed to, get it onto even terms. So this times 4, oh my god, 120 plus that 8, 28. What's that times 4? And this is times 5, which is 160 over 20. So now this is negative 32. Negative 32 over 20, which reduces to negative 16 over 10, which is 8 over 5. Is that correct? Who knows? Really, who knows the answer? It is correct. So now, what they're telling me, and it's not negative, so I don't know how I got a negative number, but I'm just happy that I got it like the right number. So, oh my god. So now we have 0, negative 16, and 8 over 5 from my whole mess over here. And it equals negative 72 over 5. So I think I almost have a good idea. I almost have the gist of it. Okay. Am I allowed to take an hour, a 15-minute break every little while, or is that not allowed? Hold on. Recall for definite integrals, line integrals possess a similar property. It's shown that p dx plus q dy equals negative p dx q dy. You just add the negative whatever. So basically what they're saying is that, okay, they're giving the idea that this, it goes this way, and then this, it goes that way. Let's say they're the same. This is a positive and this is a negative line integral. But even though one's positive and one's negative, it doesn't matter because it's going to turn out in the same way either way. Regardless of the something or other. So now we look at line integrals in space, which is, basically they're talking about, okay, here's a line integral. Oh, it's on a 2D blah blah blah. It's on a 2D plane. Oh, here you go. It's a line. Now they want you to do y, x, and then z. And they're gonna be like, oh, it's this way. Oh, blah, blah, blah. It went down this way. Holy frick, I hate 3D space so much. I wish we lived in a 2D world. I could jump like Mario or something, and I could do like a, in Super Paper Mario when he like flips the screen around. It's like, oh, yahoo! Let's go this way. That would be so awesome. Like, if I was like stealing stuff, I would use my 2D ability in order to go 2D so the police couldn't catch me. Okay, anyway. Basically, they babble on about, dx, dy, and dz, ds. And then you add a fourth one with respect to z. I wonder. So basically, nothing much changes. It's just like, I don't know. How am I? Okay, basically they add 3 spaces and they're like, okay, fuck you. Why don't you do it again? They say, okay. They say, do whatever you want, man. Z, dz. And they're telling you x equals 2 cosine t, y equals 2 sine t, z equals t from the interval of 0, t, and 2 pi. Okay. Okay, sure. Yeah, sure, man. No problemo. Okay. This is all to help me be better. If I do this, something good will happen to me. Hard work will not betray you. Hard work will not betray you. Hard work will not betray you. Bro, I was wondering, like, what does hard work do? Oh, it doesn't betray you? Yeah, that's great. Okay. So, for the solution, well, let's not look up the solution yet, but here's dx, dy, and dz. So now, basically, what they want me to do. Wait, no way. Do they want me to find all 4? I just can't help but spoil myself. No. Hold on. They want you to find dx, which equals negative 2 sine t. I want you to find dy, which equals 2 cos t, and they want you to find dz equals 1. So now you take it and you plug it into here. Y is 2 sine t. 2 sine t multiplied by dx, negative 2 sine t plus x, which is negative 2 sine t. No, that's dy. Dy cos t. Okay. And plus dz, which is just t. Okay, so now what they want you to do is multiply it all in, and then take the integral from 2 pi to 0. Take out all the 4's. 2 times 2 is 4, times 2 is 8, times 2 is 16. Negative 16, yeah, it's negative 16. Negative 16 pi 0. And then here you have sine squared t plus cos squared t plus t. This equals 1, right? So now you have 16 2 pi 0 1 plus t. And now you take the integral, you get t plus half t squared, you get 2 pi 0, you get 2 pi plus 2 pi squared is 4 plus 2 pi again. So you got 4 pi multiplied by the 16, that's negative 16 too. It's negative 64 pi in a hypothetical scenario where I'm always correct. Yep, it's not correct at all. It's actually 2 pi squared, so I think I should go get hit by a car or something. Okay. I hate mathematics so freaking so much. Oh my god. Can I just be right for once? Is it illegal for Silly Guy 99 to be correct? Oh. Just let me rest for it. Let me tell you about this book I was reading. It's called it's like called like philosophies, or like the, you know, how the early philosophers got their thoughts. So I'm reading it. Oh crap. And basically, you know, it starts from like the Greeks, and they discuss like, okay, blah, this happened, like matters and atoms, and they figure that out, and then they go to like the religious times where all the Christians are like, okay, God did everything. And then I'm close to like the, I don't know, I think it's called scholasticism, where they're talking more about religion, but it's kind of interesting to see like how I don't know, how something, just like how, oh god, I should just read the book again. I don't know, just the evolution of philosophy is interesting to read. But hopefully I learn about all the philosophies and I read a bunch so I can learn more. The next book I want to read is probably The Metamorphosis by Franz Kafka. Plenty of books to read this world. I think I'm gonna read all of them, but anyway, doesn't matter. I have to figure out this stupid thing. The double angle formula. Okay. Oh my god, I think I have to look it up. The angle. I deleted TikTok. I already told you guys. How could sine squared plus cosine squared equal the double angle formula when that's like 1? Okay, no, it's not. They're not being subtracted. That's not a double angle. Okay, this is stupid. 4 cosine 2t plus t pi and 0. That's 2 sine 2t plus t squared over 2. Okay, 2 pi over 0. My writing, okay, sorry, my writing, I notice it gets so messy when I don't know the answer, because like I'm just not trying anymore. So I think I have to like kind of get a grip. It gets so messy. We use the concept of a vector to write a general line integral in a compact fashion. For example, suppose the vector valued function x and y, t, x, y, I, blah blah blah, is defined along a curve x, f, t, y, g, a, t, this, and basically what they're trying to tell you are I equals dx over I plus y over j. And then they're writing all this stuff. This is really important, I know. The f times dr equation, but hold on. God. I just said hold on like 3 minutes ago. Okay, no, not holding on. That's why. Y plus y c times. This is like the whole formula that they are getting at dx dy dz. Where it's like p q r f d r times r. Like what they're trying to say. Now they start talking about like workers. Oh, I forgot I was supposed to. I still have these home questions to do. I have to solve. Okay. Well. Oh, and I already did this whole chapter. Didn't I? Okay. Talking about. Okay. Get the book. I if I did it. But like a times. Because it's important that I have. Here, here it is. F equals xi plus ij. But with the curve chased from rt equals cosine ti plus sine j. So basically, what they want you to do is find FDR. So here's f, xi plus yi, dr. Just take the derivative of this. So times, or is this the dot product? I don't know. Negative sine t plus cos t I and j. Like supposed to multiply into each other. It's supposed to be like both of them. I'm really tempted to check the answer right now, but here, how about this? xi x y the odd. Someone save me. Oh, you're supposed to find the parametric equation. But you weren't supposed to. Got it right though. Not the. No, I didn't get it right. Okay. Not what I. You're supposed to figure out that. You know what you're supposed to figure out? You're supposed to figure out cos t and sine t is x and y. So now you get cos t plus sine t. Then you multiply by negative sine t plus cos. Something like this. And then. And once you multiply them, It's like a dot product. Out of gas. How's that even possible? I'm tired. Okay, for same thing. Well, God, messed up. Talking about something like circulation. Like now it's just weird. Things like around F times dr, F times TD. Okay, arc light. Case of two. Okay, sizes sitting around. Okay, ready? One xy equals two xy. What they're asking to find the curve. Asking failure to find okay, sorry, pi over 4. Now what they want you to do is take this 2xy and replace it with whatever's inside. 2 5 cos t 5 sine t. And you take it from when you multiply, then when you do the respective dx, dy, and dz times dy, dx, and ds. Saying that 100 times fast. 5 sine negative. Now you take the 5, and the 2, 5, 25, 125, and take it all out, 250 negative pi over 4. So we already did this. Cos sine squared t u equals cosine sine d cosine. Get the idea. Goes over. This becomes u squared. Becomes 1 cube. Place it back with sine cube over. So pi over 4 sine. Actually, it's not sine 90 degrees. 108. It's 45, so it's 2 over 2. Root 2 over 2 times itself 3 times. 2 root 2 over 2 times 1 over 2 over. Is that correct? I guess you can take this and this and it 2 over 12. Let's go. Oh wait, I'm not even done yet because I have to do it for y, x, and z. Or for y, I have to do it for y and s. Okay. Wow. If I work hard, something good will happen to me. So now for dy, you just take this again. And you take out the what y is. This is y, 5 sine. Okay, so 5, 5, 5 to 250 again. But now it's cosine. Cos 9t. Taking the derivative of this is cos t. Now you have cos squared t u equals cosine du equals negative sine squared negative sine t. So now replace it again. Becomes u squared. This becomes sine. This actually becomes negative now. Now it's 1 over cosine cubed. Do it pi over 4, which is still root 2. How did this? I did all this and then it became, and then I multiplied it by 250. Did I forget 250? Okay. I forgot the $2.50. Root 2 over 2 cubed. 2 root 2 over 8. And then 0 is actually 1. 1 cubed minus 1 over 3. All times 200. Why did I multiply here? Oh crap, I'm cooked. Gonna have to start it all over again. Wow. God. It sleeping for a pass out. Possible. Slept for 6 hours, but my God. Like, I think I'm awake and then I just try to get up, right? Tired. I think I said, how many times did I say that? Probably 5 times. Tired. No, no. Okay. What if I just didn't? No. But also, they're right. Okay. Let me try again. One more time. The derivative. It all out. 5, 5, 5. Cos square. Cos sine. Cosine. Cos. Get out of here. And squared. Squared. Over 3 cubed. Over 3 sine cubed. 90. 0. Okay, root 2. 2 over 2 times root 2 over 2 times root 2 over 2. 2 root 2 over 8 or root 2 4 minus 0 times 1 over 3 2 over 12 times 250. Okay, so actually I was right before. Good. 555. But this time it's not negative 5, it's 5 cos d. Now 555. Now it's positive 250. It's cosine squared sine. So now u equals cos. du equals negative sine. Take out the negative. Take this out. That's 1 over 3 cosine cubed. Root 90 degrees is root 2 over 2. So root 2 over 4, we already got it from here. Multiplied by 1 over 3 root 2 over 12 times negative 250. This was also negative 250. So now it's negative 250, 2 over 12. And now you multiply by now you do the arc length formula. Is here is, since you have x and y, 5 cos 5 sine, it's going to be this, and then it's going to be rooted down into, you're going to have 2 5 cos t 5 sine t, then multiplied by 5. Now you're going to have the thing, and you pull everything out again, so it's 250 cosine sine. Do this again, and you do u substitute again. So I'm going to say today u equals cos cosine, negative sine, get out of here. Negative 250 cosine. Do all of it again, except this time it's half cos squared. Now you do root 2 over 2. Do 2 over 4. You get 2 over 4 times 1 over 2, which is 2 over 8. So you get 1 over 4 multiplied by 250. It's 250 over 4, which is, I don't know. Now you add it all together, and what you get, who have to go look. Something, right? 6 5. When you look at the answer, and it's yep, this is right. 125 over 2 is correct. This, what I even do here, negative 200, 2. I even circle this one right. Minus 4 divided by 12, where the minus 4 comes from. I can imagine that I'm not 2 of them. Okay. How long does it take me to do one question? Not even close, man. Look up the Pantheon. Get the recommended. This feels like it's really thing here. All of them, then work on question 3. Square. Okay. Okay, let's get started. Shall we get started? By x. I think you're supposed to do this. How come they have x but they don't have y? If I just took x and if I do x, then it's going to equal y. Okay. X I minus. I think you're supposed plus square. Three x squared squared plus 6. Okay, and I enter. Supposed to come back. Where's my dx? 7 squared 6. 27 x cubed plus 2x squared plus 6x. Now you do 0, 0, minus 1. Negative 27 over 2, 6. This is 9. 9 plus 12, 6. It's negative 15, so it's 3. Answer is 3. What about for y? How am I gonna solve it for y? How do I even solve it for x? Oh, do you know why? It's supposed to be like that formula that we did a while ago. Oh, but I just forgot it. Cause I'm an idiot. Cause I'm an idiot at this game. If I wasn't on stream, I would just skip to the next section and start reading. But that's why I turned on the stream. If it takes me forever, I still have to go. Get better. Right now I'm just looking at the Twitch page. Twitch. Oh, fun. Okay. Even if it's wrong, we still have to go to the next one. I don't have a choice. You go here and then you do this. So basically, I'm supposed to do all that over again. 3x squared. Okay, so this is going to be the same. 7x x 6. And now, what I'm supposed to do is I'm supposed to take the derivative of this. So now it's multiplied by y plus 2x plus 1, so it's just 2. Now, since everything's multiplied by 2, it's going to be 54 plus not 22 is 20. Now I take the derivative square. Now after all that, it's gonna be really 1 over 354 54 over x cubed plus 48 over 2x squared 12x 0 to negative 1, so 0 negative 50 plus 8 over minus 12. 54 is 60, it's 18, negative 18 plus 20, 12. That's a minus 30 plus 24 is 6. I should have known because I freaking multiplied it by 2, so it's gonna be that. And I have to find the arc length now. X squared plus y. So does this count as x? Or what am I supposed to look at that answer? 3, 6, 3, 5. However, I have to go back and review what I did. I literally don't know where. Of all the slop that I wrote, it's here. X f of x. Because the function of x 1 plus f of x squared dx. So 1 plus this f of x, which is 2x plus 1 squared, which is 2x plus 1, 2x plus 1. 4x squared plus 2x plus 4x plus 1. So it's that. It's 4x squared plus 4x plus this 1 is a 2. It's rooted. So that's what I'm multiplying it by. Which is 2x plus 1, 2x plus 1. But even if you add them, like, isn't it just gonna become God. I think I just pulled a bunch of imports and metal stuff out of it. I just ruined my like when it breaks up all the metal wiring side gets exposed. Look. See it? What's this? Focusing. Okay. Get the idea, it's broke. But it still works. Okay, get back to work. Seven x 6 divided by 4x squared is 4. So basically what they're telling you is that this is 2x 2 2. They want you to multiply it by whatever is in here. Thing Now, why don't I just skip it? How about I just skip it, okay? And go to 5. Question 5. Water break. Okay. 2-hour mark. Let's go. G of x, y, and z. This is supposed to be a g. Equals z. What does that mean? X equals cos t. Y equals sine t. Z equals t. Oh, from pi over 2 0. So it means this whole thing equals z for some reason. So that means t, and they want you to do d cos times dx, which is sine t, so times negative sine t. And then, guess it's like t sine t. T sine t. You're supposed to integrate it by pi over 4 or 90 over 0. So t sine t, I don't know. Like I really I really have no idea. You can't even factor it out. Are you supposed to do integration by parts? I forgot. I literally don't know how to do integration by parts. I'm so stupid. Integration calculator. Negative x sine x. Oh. I wonder how much money this guy makes off his integration calculator, because everybody uses it in the whole world. It should be famous, right? Yep, it's integration by parts. At least I knew. At least I knew that it was the right one. Integration by parts, I'm skip it. December the 1st is in about 1 week. Okay. Hopefully. If I don't know integration by parts, I'm gonna get cooked on my exam. Don't know. Let's just look. Okay. And problem 7 to 10. Hey, skip another to this one anyway. 7. So question 7. Y equals 1. Y equals x plus 3. Now they want you to evaluate on the given curve between 1, 2, and 5, 2, 5. Okay. And they're saying here, negative 1, 2, go 2, 2, go up. Okay, and they're telling you that the curve is 2x plus y dx plus xy dy. So here, let's focus on this part. It goes from -1 to 2 on the x-axis. So let's focus on x. X equals 3, dx equals 0, leave y alone. And y equals x plus 3. So since y, this equals 0, so we're supposed to go here, and we're going to x plus 3, dx is 0, so it doesn't matter. Plus xy, 3 times x plus 3, so it's 3x plus 9 dy. Oh, that's not how it works. Yeah, it is how it works. From the bound of but if you're integrating with respect to y, then what's going to happen to x? Oh, also you guys can't see. Okay. Well, I just take a breath. I literally have to go back to the thing because it looks like I didn't learn anything. Hard work will never betray you. Hard work will never betray you. I'm not working hard yet. So should I do it in terms of dy? If I do this, then it's gonna be well, all I have to do is take what dy is, which is 1. Now it's 1 and now it's dx. Wow. I'm a genius actually. And actually it's not 3, 0, it's 2 to -1. So now, okay, what a mess. 3x plus 9 dx. Take the integral. 3 over 2 x squared plus 9x to -1. 4 times 3, 12 over 2 plus 18 minus 3 over 2 minus 9, where this becomes negative and this becomes positive. Now you have to take it 2 over 2, 6 plus 18 minus 3 over 2 plus 9. 9 plus 6 is 20, no, 9 plus 18 is 27. 33 minus 3 over 2, which is like, I don't know. It's like 32 and a half. 31 and a half. So now what if I go look at 7? Oh, and I forgot to do the I have to do the next one. Okay, I'm so close. Come on. 31.5. Let's look at it like that, and now we have to look at this. Go up here. So here's 5 to 2. And my parameter is going to be y. So, but we already know what is y, so we just leave it alone. Y is going to be y equals x plus 3, dy equals 1. 2x plus y. So plus this is going to be 3x plus 3 plus xy, x times y, x squared plus 3x dy times 1 dx. Now you take the integral of this, but it's going to be like x squared plus 6x plus 3 is going to be 1 over cubed x cubed plus 3x squared plus 3x. Now you do, holy mess. Now you do from 5 to 2. Couldn't even be an easy integral either. Freaking bastard. To 125 over 3 plus 25 plus 75 plus 5, 3 times 5 plus 15 minus 2, 4, 8, 8 over 3 plus 4, 12 plus 6. Here's my equation. Freaking slob. What if I just put this into a calculator? 75 plus 15 is 90. 102. 108 plus these two, 125 and 8. So it's 130. 133 over 3. So like 99. So it's like 132 basically, which is I don't know, 40. 33 is 11. 11, 22, it's like around 44. 132 is like 44 point something. And this is negative, right? No, it's okay. Now it's actually 128 3. Yeah, you freaking bastard. And obviously that answer is wrong because the other answer is it's like 21. So basically I'm just a tweaker. Okay, well what do I do now? Those were like the easy problems. Now it's about to get way hard. Also, like, what am I even doing here? So it's like the ramblings of a schizophrenic man. Okay, let's go to just a blank piece of paper. Play Geometry Dash. You know, I recently bought Geometry Dash and I'm actually really good at it. Then I'd have to set everything up. Think I could do it. It feels like something bad's gonna happen if I do that. Try not to get in trouble. Or I should, I want to keep the videos like separated. Because I don't know. Like the Grapefruit does that. I just copied all of his strategy. I don't know. I like the format. Steal it for myself, right? Because I'm a thief. Okay, let's go to the next question. 9. Okay. 9 doesn't even have a freaking 9 doesn't even have an equation. What am I supposed to do with this? Where's my equation? You know what? I'm skipping. Let's go 15. Evaluate 6x squared plus 2y squared dx plus 4x dy, where c is given by x equals root t. I got a freaking Alright, I just remembered something like really embarrassing. You ever get that? Like sometimes I remember something really embarrassing, like, you know, when I'm just walking around and I just start like freaking out and stuff. I start like tweaking. Okay. basically dx is well, this is t half, right? It's gonna be 3 over 2, 2 over 3, t 2, 2 over 3 t 3 over 2, and y is like well, if you take it with respect to this to y, like shouldn't it equal 0? But I don't know. What do I know? So now you're supposed to take it and you're supposed to plug everything in here. So here's x squared, 6t since it's x squared, and then this is y squared, so it's t squared plus 2t squared dx, which is times 3 over 2t 3 over 2 plus 4x. So 4t root t dy is 1. So now what I'm supposed to do is I'm supposed to take the integral of that from 9 over 4. But first, let's take out this 3 over 2, the 6 and the 2. So 6, this 4, this 3 and this 2, and this 6. 6 times 2 times 3 over 2 times 4. Well, times 1, but like who cares, right? 9 over 4. T plus t squared. And this is actually multiplied by this one. So it's not that. Okay. It's t squared plus 2, so it's t5 over 2 plus t squared, so it's going to be like t 6 over 2, which is just t cubed, plus 4 root t, and then 6, 2, 12 times 3 is 36. 2, you know what, that's going to be 15, 18, 4, 40, plus 32, 70. Okay. 72, 5 over plus t cubed, 4 root t. Okay, my whole thing's getting curved. Now, you add it together, it's going to be 2 over 7 t 7 over 2 plus 1 over 4 t4 plus this is going to be like, didn't I take out the 4? Yeah. Plus 2 over 3 t3 over 2. The 72, about that later. Now it's 9 and wow, isn't this like kind of ridiculous? Because now I don't know how to do it. So now I gotta pull out the calculator. T, I guess like it's 9 to the power of 7 2 divided by 7 times 2. Okay, it's not even like a correct number. It's not even a proper number. So that's how you know you did something wrong. Seven, 2. 2 over 7, 2187. If you have a calculator on you, you can probably do this quicker than I can. Okay, this is embarrassing. 6561. 6561 over 9 to the power of 9 to the power of 3 over 2. 27. I can do that one. That's 4 plus 54 over 3. Now minus 4 power of 7 over 2. 128. 2 over 7 times 128. 4 to the power of 4. 4, 16, 64, 256. Plus 256 over 4. This. Plus 4 to the power of 2 over 3. 4 to the power of over 2 times 2 plus 16 over 3. This is like this is it. 2187 2 14 17 3 4 4 3 7 7 plus 6561 over plus 54 over 3. Yeah. Cooked. Minus 28, so it's like 53 6. 256 over 7 minus 256 over 4 minus 16 over 3. So now 4374 minus 256 4118 over 7 plus 6561 minus 256. So already you can probably imagine that this isn't correct at all. I can imagine. I don't have to like, it's just gonna turn out like so ugly. Probably shouldn't turn out like that, and also like the shape was not that big. 38 over 3. So this is the answer that I got. So 4118 divided by 7 okay, equals plus 6305 divided by 4 equals plus comma d8 over. So I got 2177202. You're not getting a whole number, you know something's probably not. You go to question. What question was I even doing? Question 15. You go question 15. Whole time the answer is 460. Obviously. Been here for 2 hours and 22 minutes. I think you can tell I'm not very intelligent. However, if you work hard, hard work will not betray you. However, I think the person who made up that saying is might not have been telling the truth. So you know what, instead of skipping the question, I think I have the resolve to start over again. Yep. Wonder how much paper I used up. Okay, I don't know how much left I have in me. How much strength I have left. Oh, and I just said I was gonna solve the question again. Okay, how about we don't do it? Go 17. Gosh. 2x cubed y dx plus 3x plus y, where c is given x equals y squared. And then they're saying from 1, -1 to 1, 1, which actually I don't know what that means. So basically here there's no parametric equation, so that's why they give you 2 coordinates. And then, I don't know, I have so many questions, but maybe I should just wrap it up. You know, it's not even like half of the questions I'm supposed to do. It's not even half. And I'm supposed to do like another one. And another one. Hopefully it gets easier as time goes on. Obviously, it's gonna get harder. Okay. After this, I'm going to end the stream and then I think I'm gonna start it up again so I can play a video game. Maybe what I'm gonna do. Okay. Let's finish this problem. My reward. X equals y squared. We're gonna do it in terms of y2, y6, y dx 2y y plus 3y squared plus y y. I think the problem with me is that I just get so messy. So this is 4y8 plus 3y squared plus y y. Integral from 1 negative. So this is x and y, so 4 over 9 y9 plus 3 over 3 y3 plus half y squared. So it's 1, -1, -4 over 9, -3 over 3, which is just 1, but plus half, minus 4 over 9, minus 1, plus half. I guess it's gonna be go away, go away. No, 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 no. So it's -2 minus 8 over 9. -18 over 9 minus 8 over 9. -26. 9. Let's go look. Hey, it was actually correct. I was actually correct for once. Oh my god. Should we end it on a W? Oh, you have to keep the winning streak going, right? Am I right? So actually got it right. Well, it was negative when it was supposed to be positive. Come on, cut me a break. Give me a break, man. Genius. Okay. I just did 17, didn't I? Did 15. Just did that one. So now I have to go to 19. Okay, this is a parametric equation, so there's no way I'm gonna get this right. It's a semicircle, so I have to find the parametric equation for a semicircle. Or is that 19 or that? Yeah, it is 19. Okay. Well, that just happened. Squared. Squared. Okay. Sorry, I drew it really ugly, but it's supposed to be a semicircle. Like, it's supposed to be a perfect circle. So, therefore, that means that it's supposed to be cosine plus, like, x is supposed to equal sine, and y is supposed to equal cosine, vice versa. You go and you look and you're like, oh, formula of a circle. You know, they call half of this, they call a circle cut in half a semicircle, but they call a sphere cut in half a hemisphere. Why didn't they just call it a semisphere? Because then it would just be like a lot more convenient, right? Okay. Alright, I should have looked up formula. Well, I just looked that up. Welp. Okay, I guess it doesn't matter. Might matter. Because you're supposed to... Okay. I think you're supposed to evaluate it in just one thing. So okay. So the last question. So that for the last question. What if I just did that until I completed everything? Wouldn't that be really good? Okay. Ready? I'm gonna use this new tech. Squared equals 4 minus squared rooted Except you can't root that stuff, can you? Can't root the can't root a negative number. How am I supposed to figure this out? Well, I guess if you root everything like this, you can do x equals 4 minus y. Is that allowed? 2 minus. And now I can fill it in with x squared plus y squared x minus dy. So that's the formula. And that's the expression that we're given. 2 minus y, 2 minus y, 4 plus 4 minus y plus 2, y squared, then dx, get a negative y, or x minus 2, 4 minus y, y times y. Okay, what a mess. I have no idea what I'm doing, so I'm gonna go to bed now. I'm gonna hit the stream button again. What do I do? Because I don't work hard, then it's gonna betray me. Because hard work will not betray me. Hard work will not betray you. But I go to bed and I come back in the same day. I promise that I will do a second stream of mathematics today. I pinky promise. No, because what if I don't keep a promise and I betray you guys? You know, hard work will never betray you, but Silly Guide 99 might betray. Okay. I think I'm out of gas. You can subscribe. Something. Has this thing even been picking up my voice? Okay, whatever. Probably doesn't matter. It's probably okay. Good night. Bye.